Всем привет. Меня зовут Себастьян. Я работаю в качестве евангелиста программного обеспечения для IBM. И я учу русский, но я еще плохо говорю, поэтому I will talk in English. And thanks a lot for this introduction and for having me. And yes, we will talk about some experience with deploying with zero downtime, especially with Kubernetes and with some cloud native environments. So about myself, I usually do a lot of things with Java, but also anything that is related to enterprise systems and enterprise applications. And I use a lot of what is called cloud native technologies, such as containers, Kubernetes, Istio, and all these things that we will talk about today. And especially if we talk about disruptions, because if we deploy something into a containerized environment, and especially with Kubernetes, then it promises us that we can have a lot of things out of the box. So there's a lot of things that we get for free if we use Kubernetes, because it has been built with production readiness out of the box. If you look at the website, it comes with a bunch of things that we will talk about. So basically, it tries to make sure that everything works, as well as possible in your application, that you get some controllers that have multiple deployments of your instances of your applications there. You get some load balancing and some service management for free, and your pods will be scheduled to an appropriate cluster. So they are managed in a way that you think, oh, that's very nice. Everything works out of the box. But we will see whether this is the case. So what I have for you is actually a project. I use Java because I'm a Java developer, but it's not much about Java actually. And я люблю coffee. So I have a coffee shop example for you. So an application that is for coffee. And I will show you an application. So this is a Java project that uses a technology that is called Quarkus with Java Enterprise. And I deploy this to my cluster. What I have here, we will have a lot of live coding and live demos, and you will get all of the code afterwards, so you can sit back and relax and just watch and try it out later. And what, of course, I have for you is some Kubernetes environment. So I will show you a lot of things with this kube control command, and then we deploy a lot of things. Again, if you have any questions, you can ask them during the show by just writing into Telegram, and we will stop for some questions. And for now, let's see what I have here. I have a cluster where I want to deploy something. And as you can see, this cluster is empty. So where this cluster comes from, I have a Kubernetes cluster here that runs in a cloud environment. There are many, many ways how you can get Kubernetes. I use a managed cloud installation for the IBM Cloud Managed Kubernetes Service. And this is what I will use here. So in order to deploy something, quickly want to show you, what I will do. You probably have seen these Kubernetes resources, such as these YAML definitions. So there's something like that available where we say, okay, we have a Kubernetes deployment that deploys coffee shop, and that deploys just some image. So whatever this image does, we don't know yet. This runs our Java application, and we deploy this to our cluster, first of all, with one replica, just with one version, and then we deploy it here, and that's all good. You probably have heard of these probes before to see, okay, when is the application actually ready? When is it ready to do something? So in our case, what we will do, I will just deploy something, and I deploy this to my cluster now that creates a few things, so a few services and a few resources that we will cover in a second. And now the interesting thing is, my application is now about to start, my coffee shop application, and we will run this here. And then a few seconds later, it will be up and running and ready to serve some traffic. And then what I can do, I have a secret script that gets the IP address of my cluster, and then I can say, okay, give me actually the coffee, and this just says, coffee. It's basically hello world over Kubernetes, but that's sufficient for this application. It also shows you a health check to see that my coffee application is up and running. Okay, so now we just deployed this, but that is nothing, not that spectacular so far. But what Kubernetes does out of the box, and you probably know this, it has these controllers and it tries to, well, make sure that your things are always in an expected state. So you specify the target state in your YAML resources, how it should look like. For example, we have a deployment and I want to have one replica. So let's see, kube control get deployment. We see that we have a deployment for a coffee shop and it wants one instance, and it is the case. Okay. Now, if we are mean and say, hey, wait a second, I have the pods here. What if I delete a pod? Let's say I want to delete the coffee shop pod. Well, then basically what happens is that the deployment says, oh, you wanted to have one pod, but now the pod is gone. So I'm quickly going to create another one and make sure that another pod is ready again. So what you will see that just while the other pod was terminating, it immediately created a new pod, which is now already up and running because the application starts up quite quickly. And then we can see, okay, now actually the application is up and running again. So if there are some disruptions, like your application crashes, Kubernetes tries to, well, immediately reschedule another one. The same is true for load balancing. If I increase the load, and then the service will just balance on all the pods available. But now what I'm interested in is the last part with rolling update deployments. Because this is the title of the talk, I want to be sure to deploy with zero downtime and what that means. Well, for this reason, I have a second image. I have a different application version, zero downtime 2. And now this responds a little bit differently. So what we can do is to say, okay, now I want to deploy this version. So I deploy this YAML again. Kube control apply. I'm pretty sure you know about this command. It just applies whatever is in the target state in your infrastructure as code file. That's very nice because I just deploy what I want to have, the desired target state. I specify this in the YAML file, and then I can throw it against the cluster, and the cluster will make sure that this is the case. And now actually what happens, it already, well, deployed the new version and it terminated the old one. So if I now say, curl again, then it already returns with the new version with a nice coffee mug. All right, so now this worked. Basically, it says, okay, deploys the new version. I can do this again. I can roll back to my old version. I can say apply again. And then while it's deploying, I can just say, okay, please give me my coffee. And also, to make it more interesting, I can say, well, continuously get my coffee, like new coffee, new coffee in a loop. I can say, okay, let's make this a little bit faster. I can ask for coffee continuously, and then I can go and deploy here and say, okay, now in a different terminal, I can deploy my application again while I have some traffic already. And then once it is the case, and once my new application is up and running again, then it will just at some point get the new response. And oh, you already saw, okay, there's something going on here. So it already showed a little bit of what I wanted to show you. So depending on whether you're lucky or not, it actually works with zero downtime. Let me try this again. So we deploy the new version to the old version again. We roll this out, and then we see once this is up and running, how fast we can deploy. So my application is starting up. What actually happens, it keeps the old application until the new application is up and running and ready to serve some traffic. Why? Because of the readiness probe that we specified. And once this is actually the case, then we see, okay, now we have the old version again. So this is thanks to the readiness probe that we actually see, okay, when does Kubernetes know that the new application is ready to serve some traffic? Well, once the health check responds in a successful response, right? Because that means that now my application is deployed. This is necessary because if we start up Java or if we start up any program, it will take a few, at least milliseconds in order to be able to serve some traffic. And we have to wait. Kubernetes does not know when it is ready because it's just a container. It just starts up a container, which is a Linux process. And then we would not know, okay, when is it actually ready? Okay, so with the arrow before, you already saw, okay, does it actually mean this is zero downtime? Because it looks good, right? But well, for this matter, and this is actually an important thing already, how can we test whether this is really a zero downtime? Because what it does, if you look at the documentation, it says, oh, rolling upgrade, zero downtime. It waits until the new one is ready, then it shifts the traffic and so on and so forth. It sounds really good in theory, but what I want to do, I want to test this. And now what I do, I have a scenario to test it. I could, why do I have such a scenario? What I could do, I could generate just a lot of load from my computer. But since I'm outside of the network, it would generate a lot of traffic in my cloud, and then maybe the cloud doesn't like it and whitelist my IP address or something like that. What I do, I have a different scenario that within the cluster, and this is this Fortio resource, I generate a lot of load, but it goes through the same, ingress resource. So it goes through the same cluster ingress to access my application. This is why I have this second, let's stop this here, why I have the second part, which is Fortio, which is a load testing tool. Actually, I don't really need load testing in terms of, how fast my application is. I just want to generate a lot of load, just a lot of requests, and see whether all of them are successful. So that is basically what I want to test for, to have the zero downtime, to see if I fire up many requests, as many as I can, do all of them return in a successful way? So if I have a connection drop, or if I have, like a timeout, or if the connection is reset because there's nothing listening on the port already or something, then I will notice it. And what I have for this is I have a script that just says, okay, test this connection here. What it does, actually, it uses this Fortio pod, I can show you, and says, okay, go to the pod and go to Fortio and try to access the other pod, which is my URL. You see the host, the external host, and the coffee. So this is the IP address, and the coffee, the same thing that I run in the command line, and it just runs it and sees, okay, it can access it. What I can also do is a load test, which just generates a lot of requests. You see, many HTTP requests per second. And now I'm actually not really interested in the result, how fast my application is, what is the response time. I'm more interested in, do I get 100% of successful requests? Does everything work as expected? And now this will run for 20 seconds. And what I want to see is, 100% of 200 okay of successful HTTP requests. So what I can do now I can start a deployment, say, do the deploying thing again, and try to make sure that, I get 100% success, right, as before. So what I can do is to say, okay, actually, I want this deployment again from old version to new version. So I change my YAML file, right? And then I can say, okay, please apply this again, apply this version, and then see, that this is up and running. And in the same time, start the load test. So once this is the case, it will, you know this already, it will slowly start up my new application. And once it is up and running and ready, then it will switch the traffic to the new one. And then at some point, we will see, oh, parse none OK code 500. Okay, so this doesn't look that good. And we see actually, oh, well, it's very few requests, 0.2%. If you would round it down, you could argue, well, it is almost zero, so, good enough. But that is basically what you get if you do the out-of-the-box experience. If you say you just naively deploy to a new version, well, then it's pretty good. It will, work most of the time. And this now really depends on what the setup looks like that you have, like how you, which resources you have inside your cluster. And, well, we will see a little bit how this works. So basically, you could say, that's not perfect. I want this to be 100%, not very, very good, but perfect, to see, okay, well, some of the connections, if I have 20,000 requests, then 42, that was not on purpose, 42 of my users got unlucky and they won't see a successful response. This was then, like a connection drop or something. So that's not good enough. I actually want to make this better. But let's have a look at what happened, because basically what I have in my cluster, and this depends how you set up your cluster environment. What Kubernetes does, I'm accessing a service basically. So that is a diagram how this would look like inside the cluster. what you have a service. In my case, that's called coffee shop. That's just the, like service notation, my application. And then you might have one or more running instances. And per default, it works via IP tables. This is like Linux routing magic that it says, okay, if you go to this virtual IP, there's a service virtual IP, then please, route it to the corresponding pods. And then inside the cluster, you also have a DNS resolution, so I don't have to actually tell the IP. I can say coffee shop, and then it ends up at an instance. But now the point is, well, what happens if it reconfigures the whole thing? My service will also implicitly create what is called an endpoint object. So what is an endpoint object? I can say kube-control get services. That gives me my coffee shop service, right? And I can also say kube-control get endpoints. And the endpoints is basically, well, for the service name, it says, what is this? This is the actual IP address of my pod. If I only have one, if I have multiple ones, then this would be a comma-separated list. I can then end up with one of the instances, right? That's just, where it will end up. That's fine. But now what happens? Well, if I get a new pod because I have a new version, once the pod is ready, it will be added to the endpoints and the other one will be removed. So this will be updated. And what happens on my nodes in my cluster, it watches this endpoints objects and then installs and updates the service rules, the routing rules. Okay, now you can imagine, well, wait a second. If it watches for them and then at some point it eventually updates them, and that's the keyword, eventual consistency, you don't have a synchronous way to say, hey, stop, wait, reconfigure, then let's go again, right? Why? Because we are in a distributed environment. We are in this eventual consistency state where we cannot just say, okay, stop and reroute, where we basically have to wait until the whole configuration is being rolled out. And now, to make it a little bit more complex with the background, what I also have in my cluster, I'm running actually Istio. So Istio is a service mesh technology that allows a few things. For example, we will have some advanced traffic management that I will show you a few features about. And basically what it does, so the interesting thing for us is it will, now this looks also funny, this ASCII art diagram. This is our pod on the left. It will insert a proxy container that is a sidecar container to our main application. Main here on the left is our actual application, our coffee shop, and there is an Istio proxy, so-called sidecar. We can see this actually. If we say kube-control get pods, that is why it is written 2 out of 2, not one, like one container, but 2 containers inside the pod. If I have more pods, then I also have more containers. So 2 per pod. And then what happens, the proxy also does some, resiliency. So for example, it tries to detect some outliers and has some, other advanced resiliency concepts. And this is, as you can see here, the same story again. You basically try to configure it and try to reconfigure the proxies, what is done by Istio. So what happens, Istio, well, again, watches, so asynchronously, watches the Kubernetes API for the endpoints and for the updates when there's a new pod and so on and so forth. And then it will configure all of the other proxies that are there. For example, my Fortio proxy that then goes against the coffee shop. And then same story. If it's in this race condition, the case that you update something that is not there yet, or the proxy thinks, okay, the coffee shop application is not available, and then it will cannot establish the connection, although it would already be there. So it's basically a timing problem of saying, when can I deploy and when am I able to switch the traffic or not? Okay, now how to resolve that? That's basically the answer, right? Or that's the important question. That's interesting here, what I tell, but how can we actually make sure that this number is 0 downtime? Well, what we can do, and this is what Kubernetes implicitly does with the rolling update deployments, we can basically say we deliberately specify a new version of our application, Coffee Shop 2, and then we deliberately route the traffic using some Istio traffic management. So this is quite interesting. Istio offers us a traffic management where we can do more things than just say, always route to coffee shop, right? We could say, oh, maybe route to coffee shop, or maybe route to this or that, or we can specify subset versions, like different versions of a single service. And this is what we do here. That is basically how we can route from one pod to well, a service and what is called a virtual service. So this is a Istio resource, virtual service, and it specifies where to go to. Usually, you saw it in my IDE, it says, well, version v1. So it says, well, match everything that has the label application coffee shop, yeah, of course, but also have a subset version that is always v1. It's not really about an application version, it's just like a, like something identifier. Okay, route to this version. And what I also have, I have these virtual service rules, which tell me, well, everything that goes to the coffee shop end up at a coffee shop v1. And everything that goes into the cluster from the gateway, from outside the cluster, it's basically the same, route to coffee shop v1. Okay, so everything, routes to v1. In this case, I could also say, hey, I could have a second subset, v2. Per default, don't route anything to v2, so this is what I do here. My destination rule specifies actually two subsets, but the second one is ignored. I can say, well, only, do v1. But I could also specify v2. And then what we do in order to deploy, I say, okay, at first, this is how it looks like, right? We have this setup, we have a coffee shop virtual service here, one rule or one subset, v1, that is being used, and my rule says, okay, route to v1. Now what we do in order to get the downtime to 0, we say, okay, deploy a new pod. Don't do anything else, don't route, just deploy a new version, a new subset, v2. And now that's interesting, it needs to be managed differently. So it's not the same Kubernetes deployment. What we do, we leave this deployment alone. We don't change this, otherwise we get downtime. What we do, we set up a new deployment, coffee shop 2 or coffee shop v2. So this is a separate deployment, has nothing to do with the first one. It just is called differently. Now this has a new image. In order to make this work, I changed this to the old image again, of course. So let me just apply this once again, so that we see a difference. Now that is the old one. This is the new one. And then nothing else happens. I just roll it out. I can actually do this right now. I say deployment coffee shop deployment v2. And then what it does, well, it creates a new deployment and it will just deploy my new version. If I then say, okay, curl test, it will still respond with version 1, and it will still respond with version 1. It's not affected whatsoever. Why? Because we do not route the traffic to it. Now we have this situation where we have a new version and nothing else happens. And then, and this is the actual deployment then, that we say, okay, now switch the traffic. And this is an Istio feature, and we can do this without a downtime. We basically say, okay, reconfigure the proxies to go to this one. And it doesn't matter if it, eventually, if it takes a little bit longer or shorter, but after a short while, all of the ones will be reconfigured to the new one. And we can do this because both are still running. So if it takes a little while to go back and forth, it doesn't matter because both are still in place. And Kubernetes does not delete the old one immediately, only once we tell it. So we can do this right now, actually. We can say, hey, by the way, routing v1, v2. Now we change v1 to v2. And down here, we change v1 to v2. And then what we do, well, you can guess it. We just say kubectl apply the routing rules. And then once this is the case, nothing else changed. It would just say, okay, reconfigure these two virtual services. And then once this is the case, well, we actually see the new version. Okay, now it gets interesting. Now what happens while we do this, while we have a lot of load? If we say, okay, load test, now let's change it back, v2 to v1 again, apply the routing again, and then do the test. My load test is still running. Now, old version, let's reapply this again. v2, apply this again. Right now, I'm constantly deploying and we see, okay, we have still 100% uptime. I can change back this routing of my Istio proxies and it's still available the whole time, because basically both deployments are still in place, both applications are running, and it depends when we will just generate traffic. Now let's see, I think the new one is in place already, and you saw I switched it back. I can do it again. I switched it back a few times while the load test was running with like 20,000 requests, and I can say, okay, go back to v1 and so on and so forth, and then apply it again, and then have a look at the test whether it actually works. So this is the new version, and my load test is still running. It did not report any error, and I expect 100% uptime. So that is now what I'm doing here in order to solve this problem of, okay, that I don't want to lose a single in-flight request. That's basically what it means to have actual zero downtime. So in my case, this is what works here. So I can make this manual transition of saying, deliberately deploy a version of my coffee shop deployment. This will create the pods here, and then wait until everything is up and running. I can take all time I need, and then I deliberately, manually kind of reroute to the new version. Now, of course, this should not be done in a manual way. This should be done automatically. Why? Because, well, you want to have some automation here. You don't want to do the manual steps. So what you can do, you can write some templating to say, okay, generate a new deployment, then roll it out, then wait until it's there. You can test it, then switch the traffic, test it again, then take out the old version. What happens here? So afterwards, I can say, okay, once this is transitioned, I can take down the old deployment, and then I'm gone. But of course, that is not the ideal way. What I want to have some other technology, so I don't want to write that script myself. And there is already something out there that I will use, which is called Flagger, which can implement this approach, and it can do a little bit more, what is called progressive delivery. So that is another topic, how to make, these rollouts a little bit more sophisticated and to build a little bit more quality in. What progressive delivery means is that I want to limit this blast radius if something goes wrong, like blast, like blowing up of my application, by not rolling out everything at once, but progressively. And this is implemented by this technology, what is called Canary Releases. So you say, okay, I don't want to roll out all of my users, all of these 20,000 requests to 100% of the users. I want to start small. Let's do 5%. The rest stays on my old application, and then I can gradually increase the traffic. Now, this is what I want to show you next in this demo, but we can wait or we can stop for a quick moment and see if there are some questions. Alexei, do we have some questions in the chat for now regarding the first topic, how to do actual zero downtime?
Yeah, we do.
Okay.
First question is more like a tooling question from Dmitry. He asks, why don't you use the conventional and convenient shortcuts for kubectl, like kcgp is kubectl get pods? Do you understand the question? Is it only for representation?
So the question is, if I use the shortcuts and I use some aliases. So if I say, kube control get services, I don't write kube control get services, but I say,
you do. You just expand them. Yeah, I see.
Yes. That is my command line configuration. When I have an alias, it expands it. I think that's a feature, because then I see, if I just say kcgs, then I don't know, or is it get services or get secrets or get what else do we have? So it's I always want to expand them, that I see what I'm typing. But that's it's a very good question. If you use Kubernetes a lot, you should set up aliases. Like get pods, get services, get deployments, apply, delete.
Yeah, I totally agree. Another question from Dmitry, but from other Dmitry in our chat. He asks, is it possible to achieve a really zero downtime with a Java web application? And he asks, is it only about switching routes or something else? And also we have a follow-up from another user who asks, what about database migrations or upgrades? How does it affect?
Yes, I like when attendees pay attention and they guess the next topics. Yes, database migrations is the big one. We will cover this a little bit later. Wait 10 more minutes or so, then we have this. And whether it's possible to achieve it with Java applications, yes, of course. First of all, it's not about technology at all, because I'm actually using a Java application, if you saw it. But it's not about what you run, because you just start up a Docker container, right? And the Docker container could be whatever. In my case, it's this Quarkus application. I can show you actually the Docker file. So this is the Docker file of my application that uses some Java, OpenJDK with OpenJ9, and then it will inside have some java-jar. But it doesn't matter. Why it doesn't matter? Because I just start my application and then I wait until it's up and running. And I see whether it's up and running with the health check, with this readiness probe. And it doesn't matter if it's, if it's some Go or some native that starts up in 200 milliseconds, or if it takes half an hour. Then it will just wait half an hour and I say, okay, then I'm, deployed. And then you do the actual deployment. So this is what I'm doing here deliberately by switching the traffic. So here, if version 2 takes half an hour to deploy, it doesn't matter, because in the whole half an hour, version 1 is still there, and then you just shift the traffic. But luckily, modern Java is really fast. You saw it starts in less than 10 seconds. So.
Okay, we have some more questions about your tooling, but I think we can postpone them to the end or to the discussion zone, because they're not about your topic exactly. And we have some questions. We have some questions about your topic. Next one is from Raman. He asks, are there any alternatives for Istio that we should consider? Because he knows that it's very invasive and you have to remove the ingress controller and use only Istio.
Yeah, or at least you should use the different controller to get all the features. It depends really what you need. So Istio, it's, I would say, somewhat a de facto standard for a service mesh technology. There's also Linkerd out there. It just depends what what features you need. If you need all of this traffic management and then the configuration, you get a lot of monitoring and observability there for free. It depends what you need, basically. You might have a look at Linkerd. It's like Linker and D, which is also service mesh technology, and uses slightly different approaches. But at the end, it just depends what you need, right? Because if you do such a thing like traffic management here, it always means that you have some type of load balancing or some type of proxy that switches things, right? Like the Istio proxy that is part here. So whether that's part inside the container, or you say you have a different proxy somewhere else where then you connect to, which then does the logic, you always will deploy something and configure it. And what I would just go with, or what I advise my clients, is to use a technology that is, a standard or a de facto standard, because then you will find a lot of resources. The people are, or it's more likely that people know about it, how to use it, and things like that. So this is what I would consider for that reason. But if it's more like a question whether you need a service mesh technology in general, to say, okay, do I need all of this traffic management and authentication, authorization, all the features that you get by Istio, or what do I want to go with plain Kubernetes or not? So this is what I would do. This is also true for the next topic I will show you with this Flagger technology. You can also do this yourself with some scripting. And the question is just, it's probably more safer.
Okay, just one last question from me before we move on. I have a question. I see that I hear it. I listen to your talk, and it's all quite complicated. Why isn't it all built into the Kubernetes out of the box? So you'll have to make some hand waving and some configuration, and maybe write some operators. Why isn't it built in?
Yeah, well, and that's a good question. It basically, I can say it constantly improves. So it's it already supports many more features that haven't been there out of the box or in the beginning. What you can actually do. So this is a little bit because of the setup I'm using with Istio. If you use plain Kubernetes, then you also have to, like make some adjustments in the configuration, like how long can my applications take time to shut down and things like that. But then you can actually achieve zero downtime without some extra hand waving, like you say. It is, it's basically a little bit of a trade-off of how complex the system is, and what makes sense to make a trade-off. Because if you go from a very easy example, like like Hello World, you can say, okay, I built my own Kubernetes with that supports Hello World, but then you use it for something else, and then you need more features, and then you have it maybe with some asynchronous communication, and it's a little bit the nature of this high distributedness of my system, because now I have a Kubernetes cluster with only 3 nodes, but I could have one with a few thousand nodes, and then it's a different story. If you say, okay, can I make it simpler and can I build it in? Well, maybe then it doesn't scale that well, right? So there have been a lot of considerations why it's being built this way, and I think it provides a lot of value still. If otherwise, we would need to do all of this ourselves, I would say.
But is this zero downtime really a worthy goal to make such a complicated system? Is it such a valuable thing? This 42 failed requests.
That's also a good question. It really depends. Because ultimately, it's a little bit of the question what service you want to or you have to give to your users. So how are the users using your system? If it's like, a customer like 9 to 5 and nobody will ever request something in the evening, then it's fine, because then literally nobody uses it. I don't want to compare it with Google, because that's always an like high achievable or not achievable example. But if you have some service that people around the world literally use all the time, then I would ask it differently. Why do you want the users to suffer a downtime if you really want to add value to the users, and not make a little bit effort on your side so that they don't see a downtime, at least not a planned disruption, right? So at least not something you could avoid. To say, okay, let's just make these transitions. And once we cover database migrations, we actually see that, okay, you will need to have some deliberate changes, like, this more complex switching anyway, in order to provide a better service.
Okay, thank you so much. I suggest we move on and ask all the other questions in the end.
Okay, perfect. So now we covered a little bit of this zero downtime deployments, and now about this progressive delivery. So what I want to show you is this technology that is called Flagger. What it does, it supports different deployment strategies. So what I just explained to you in the diagram here is that you can have something that just automatically applies your deployment and says, like pop up new version and wait until it's ready, then shift the traffic, take down old version. You can make this even a more, more sophisticated by saying, okay, do something. And this is now a different specification that is called Canary. Again, Canary Release is gradually deploying something with 5% first, and then 10%, and so on and so forth. And I want to have a look at that. So basically, you can configure how your deployment, like the actual process of deploying something, will be done. And what this does. So let's undeploy my keep control delete my example again to say, okay, deployment coffee shop. So just delete everything. It's always a good idea. And then, everything is terminating, and my coffee shop stops here. Then it's not available anymore. And what I do now, I say, okay, please apply these resources, and this so-called Canary resource will make sure that actually a deployment coffee shop will be created. So let's try this out. I have some examples here, which just create, like Canary deployment and so on and so forth, and will also, create some resources there. So it will create what is called coffee shop and coffee shop primary. So it will have 2 different branches. You can have a look at, the description here, like how this works. of, for example, saying, okay, it started with the documentation explains how to do like Canary Releases, for example, and then it will see, how it gradually will have some traffic while you have some old version, and then gradually shift the traffic to the new version until everything is rolled out. And we can see this now with, let's go to curl test and see, okay, now it works with the old version. And then I want to see some logs here actually. So let's have a look. Kube control logs. I think that's the flagger or something. And now I want to deploy my new version. So I see, okay, my application is up and running. And then what I do, I deploy. Now I have to see that I'm in the correct folder. I change my deployment from 1 to 2. And then what it does, well, let's also generate some load here, but actually I will change my load test a little bit so it runs longer, because now the deployment will take a little bit of more time, say only 100 requests per second, but do this for 2 minutes. So let's just start up a load test, and I hope and flagger deployment, deploy a new version. And then what it will do, it will just fire up a new other coffee shop version, not in the primary branch like of this Canary branch, but in the other version. And then it says here, new revision detected, scaling up. Okay, what does it mean? Well, now I just say, okay,
Sebastian, can I interrupt you?
Yeah.
I'm sorry. I think you're sharing the screen of your browser, not your console.
Let me see. Okay. Yes, that's correct. I hope. Let me just restart this. Otherwise, I would actually I'm looking at the, let's say, correct window. Otherwise, I would need to restart this for a second. Just 1 second here. Oh yeah, there's something that went wrong. I see you here. Let me just I think I have to quickly restart the screen sharing. So that's an interesting thing with my setup here, because it's a different computer that does the screen sharing, and then it actually needs to grab the output of one computer and have it into a video grabbing insert card. And then no, that's still the old one. Okay, I think I have to stop the sharing. This, just 1 second. Yeah, there's something missing here. Actually, I don't know why it happened. It seems like it froze this. So, okay, let me quickly restart my OBS. My picture might be gone for a second.
Okay. Okay. We'll talk to the audience now.
Still here, don't worry. I'll just need
sure.
to quickly. Maybe you can tell some jokes in the meantime, or
No. I think that your background and your image appearing and disappearing is a joke enough.
Exactly.
So we see you on the background of your browser.
Yes. Okay, now we should be back.
I think we'll have.
Yes.
Yeah, we have a lot more questions about your tooling after your talk. So let's continue.
I can also share some video how I make this setup. Now it works again, and I think, let's see. Oh, it's almost already advanced while we were waiting. So you maybe see the logs here. It started to 10%, 15%, 20%. So what it does, let me now just do some curl here. Curl, yeah, like this. So what we see that now, if I do a continuous request to my application, it will actually, always basically respond with a different version. This is now on purpose. Why? Because it just tells like about 50% of my users to, and now after 50%, it actually advances to 100% to go to the new version. So what I can do, I can have a look at my virtual services here. And then this is what I told you before on, so what I did before manually. What it does, it changes the route and says, okay, build up, beside the primary, build up this Canary version, and now it already is at 100% and 0%. But what it does, well, it gradually shifts the traffic. So now it does two things at once. First of all, it enables that you're able to do zero downtime. So this is what I did manually before by switching V1 to V2. But not only this, you saw it in the output, I can actually specify multiple routes at the same time in Istio. That's an Istio feature to say, okay, specify, 2 destinations and specify a weight, like 100% or 10%, 90%, 5%, 95%. And this is what the application or what this Flagger technology does. And then it will just progressively enhance this. What it also ships with, this is quite nice, is some dashboard. So I can actually have a look, or probably have to do the port forwarding again. So let's see. So what it actually does, it shows you a dashboard of comparing these two, basically these two branches of the primary branch and the, where's my load test? I can fire up my load test again, and the Canary branch. So if I now do this again and say, okay, generate some load and now do the deployment, I can actually see not only that I'm able to deploy with this downtime, but I'm also able to watch it in my monitoring and get the automated feedback whether it actually works. So Flagger deployment. If I now deploy this, it will deploy the version again, and then it will gradually shift the traffic to the new one while my load test is running here. What it does, I can also specify, and this is what I'm doing here, if there is something wrong with my release, then it automatically switches back. So that is a little bit also, the point of doing these releases is to say, hey, what if something fails? Well, if something fails, I can just very quickly switch back and forth, right? So if I get now an error, then I can, oh no, error, immediately switch back. So there are multiple approaches included in this progressive delivery approach, is to say, well, zero downtime, then try to limit the blast radius. If I have a bug in my application, if there is an error, don't roll it out to 100%. Maybe it will fail. So this is, kind of testing in production, but with a limited set of users, only 5% of the traffic, for example. And then if it works, you can automatically check this, make it bigger, make it 10%. Okay, does it still work? Okay, now do 15%, and so on and so forth. And this is what you can do in an automated way. Of course, you can write your own logic, but this is what this Canary already implements. So you can say, okay, every 15 seconds, increase it by 5% up until 50%. This is just an example. And at the same time, watch this success rate, because if it would not exceed a 99% or 100%, if there is an error, then immediately roll back and say, okay, it failed, roll back, undo, old version still. Same for the request duration, if it takes too long, for example, and things like that. And now, my load test already showed. Okay, now you see it. This is a nice specification here, how it ramps up the traffic in the Canary release up until it switches it again. So it comes with, I didn't configure this, it comes out of the box with some dashboards if you configure it too. And it will do the automatic checking for your metrics. So if there is an error here, if the success rate is not 100%, then it will say, oh no, roll back. That is basically one technology that applies this here. All right, so that is about rolling out and doing these releases here. But also, and this is now a slightly a different topic, but a very important one that we already had in the questions. Yes, it's nice if I do Hello World with coffee and just a stateless application that does nothing else than printing something or calculating something. It's a different thing if I have state, if I have a database. For this reason, I actually, let's undo all of this again. Let's stop here, and I delete everything again. That's also a helpful script to just, delete all the resources, and then it's gone. Because now what I will show you a different version of my application that actually has, oh no, git stash, no, can I still check out? Is there a force? Yeah. Now what I do, please show me some state. That is now my Java application. And I have now it does a little bit more. Now I have a coffee order that I could basically deploy and persist. And now it not only says hello world, I can actually order some coffee now, which will be stored to a database. So don't worry about the Java code, probably, or maybe you're not a Java developer even. So this is Quarkus code, but it does not matter. It's now a little bit about the application code, because now the application developer actually has to do some things in order to enable database migrations. So why is this a topic? Let me show you. Assuming I have a schema, a database schema that looks like this. This is now SQL. It says, well, very basic database table, right? Like create table orders with some ID, status, type, super simple. Now, what happens if I say, okay, type is actually a bad name? Assuming I want to rename this, or I want to change the type, or I want to do some form of database migration. The interesting thing is to be able to say, okay, please don't update in jumps, but update in steps. Why? If you can imagine, I want, database migrations, why doing zero downtime deployments? Then if you don't have any downtime, you don't have any chance to migrate, right? If I say, okay, now drop column type and insert column coffee type or order type or something like that, and copy the data, well, then you have some downtime. And if the application still wants to access type column, then the type column is gone. So, this will not work. Basically, what you have to do is to make sure that you migrate in small steps, and mostly that you have a version that is compatible with application version N and N plus or minus 1 at the same time. So that basically you're able to do these rolling updates. And this is called N-1 compatibility, to be compatible with two versions at the same time. So now in this case, what we can do is to say, okay, first of all, let me deploy my application. Deployment coffee shop. Is it this one? Yes. What it does now I only have one coffee shop application. It's a different version now. This is my database version. I can show you. This one is now important. It's called, that was the wrong version. I wanted to start with the first version. Check out DB migrations. Otherwise, I showed you all of the trick already. So let's see whether this works. And now, once that is up and running, we see, okay, it showed, let me see. I have to delete my Canary, otherwise it tries to now gradually. Actually, I thought I deleted everything, but I did not. Okay, now everything is deleted, I think. Because otherwise, yes, otherwise I show you two demos at the same time, but it takes too long if we now always wait for the Canary for the database migrations, because now we will deploy a few times. So now let's do it again. Apply just this, and then it should only create one pod. Now, what I do, this pod will access a database. So where is my database actually? In this case, I use another we can close this now. We can use another service. I use a database in the cloud. That's a managed Postgres on the IBM cloud. So it's just Postgres service, but rather than running my Postgres in a container, it's managed here. And I can access this and say, okay, once my application is up and running, I can actually access it by saying curl not coffee but orders. And then, oh God, I think I deployed the wrong version first. Yes, because the database was not in the correct version in the beginning. I think because my database is right here. Okay, now I think I did a mistake for, yes, it already migrated the versions, all of the versions, because I checked out the wrong branch at first, but this doesn't matter. We can actually undo this. As always, if we have, that's actually a good, that's a good outcome, because now you see what happens if things go wrong. The good news is with this infrastructure as code, we're always able to, like roll back, delete, and whatever. So let me make sure I check out the correct branch. I want to start in the beginning and then slowly show you the demo. And what I do here now, this is just my own code. I say this is a database shell for Postgres. I say, oh, you know what, drop table orders, and also drop a table of this. I use Flyway, which I will show you in a second. Why? Because then I can start from the beginning. So now my database is empty. And what I do, let me just quickly show something else. I need to quickly instantiate my database with the migrations here. So this is a little bit of magic. If you delete it, I should not type and talk at the same time. If you're interested in that, we can cover a little bit of that in the QA section. But basically what I wanted to do, I want to get to the starting state where I now can show you the demo. So now I roll out the correct version, hopefully, of my application that goes to my database, and that then, well, what it will do, it will make sure that the database is in the correct state. How do I do this? Now, if you think of it with the database migrations, this means, well, try to make sure that everything is compatible and in a correct state. There are tools available to do that, to do database migrations. And one tool that I'm using is called Flyway. It's an open source tool to basically say, okay, get the database migration scripts and make sure they're applied in the correct order. Unless, of course, like me, you tell the wrong order, something like that, well, then the tool can't help much. But basically, I want to say, do the migrations one by one. The first migration is what I just showed you. It is this initial schema to say, okay, please, first of all, create the table. That's my outcome. Otherwise my application doesn't run. Now, if the script has been executed, now you see my table is there again. Orders, I can describe the order. So this is what just has been specified. Okay, this makes sense. If I also say, have a look at this Flyway schema, then it says, oh, you know what? Okay, now it looks ugly. Sorry for the resolution. It basically says, okay, version 1 initial schema. This is the row. Initial schema has been applied. Okay, great. How has it been applied? Okay, that's interesting. What I do, I use so-called Init Containers in Kubernetes to make sure that it will be migrated. So that is a container that contains now just the first script. And then I say Flyway migrate to version 1. Okay, now it has been migrated. Now this has been executed on my database. The init container actually runs before the actual container runs, and it has to run only once, or exactly once, and it has to run in a successful way. So this was the case, and this is why my application could now start up, and I can say, hopefully now it works, I can say, okay, now give me the orders, empty, and the orders are actually coffee orders, where I can, order some latte or order some espresso, some coffee, and then it says, okay, give me the orders here, pretty printed. Okay, now I have 2 orders in the system. In the system means they're in the database. So let's have a look, select from orders, and great, there are 2 orders. Okay, that's no magic, that's just basic hello world with databases. Now what I want to do, I want to be able to change something in the code to say, this is a little bit of Java code, but don't worry, that's just an OJM mapping here, to be able to, not the ID, but to say, okay, let's change the column to say not type, but something like coffee type, right? So I want to refactor my database to do this. How do I do it? Well, I cannot just deploy this, because then it says, well, fails. It does not it does not have or find this column. If at the same time I do this init container, well, it kind of works, but it's also not zero downtime. Why? If I say version 2 and then try to do this, well, then you have a few milliseconds where the old version is still there before it's shut down, and then tries to access, well, the wrong application, so this does not work. What we do instead, well, we have to migrate in steps. So we need to apply some temporary tables or some temporary columns, actually. So this is then the second step of this migration. We need to add a temporary coffee type column first and make sure, well, this is being added. And also we remove the constraint, the not null constraint of this type. So then we say, okay, add a temporary column, then writes to both and still read from the old one. Then deploy a new version that reads from the new one already, because, like it's always one version, a plus or minus. So then gradually you can, move your way forward. That is the case. Temporary fields where you just duplicate all of the content once you save on updates, and then still you read from the old one because of the other old application that might be still there. It writes to the old one, right? So you have to apply both. And then once this is the case, let me just now deploy this deployment coffee shop deployment. Then it will gradually, output the new version. What it also does, it has database schema version 2, and schema is version 2 is what you just saw. So once that is being applied, then we actually see, okay, that we have, once it's up and running, that we have the new schema in my database, and I actually now have a new field, coffee type, and the old field type is not nullable anymore, right? So you have to temporarily remove some constraints, make it less constrained so it works to make this adjustments. And then once this is the case, we can still we can still access it, so it still works, it does not break. And now let's quickly do the next steps. Step, what was 2? Now it's 3. Say, okay, now do this again, coffee shop deployment. What the next step is now, version 3, we already say, okay, actually now we can already make the jump. We say everything that has been written in the meantime to, from the old table still, from the old application, from the old column still, write it to the new column. And now I'm already, set the constraint. So that now what we did, we just swapped these annotations to say, okay, now already read from the new one. So now the transition is almost kind of complete to say now we have the new database column here. And once that has been applied here, we can check the schema here. Okay, now it has this constraint already, and the application reads from the new one, and it still works. And then ultimately we can say, okay, git check out the operations 4. So that is then almost the last step. We say, okay, first of all, remove the code usage. So now this is what I wanted to have in the beginning. Now we actually removed it from the application's perspective, and there's no legacy code anymore. So now let's apply this. So you see this is now a little bit of manual work required in order to get there. So actually I have to deploy multiple times, but this is by design, otherwise it does not work, to have the zero downtime from a code perspective with a database schema that is compatible to what I'm doing. So now once that is the case, I want to see whether this has been rolled out. Yeah, almost. Now it should be orders. Yeah, now I have this constraint there, and yeah, like before. And now check out the latest version. Drop the unused column type, so I have a new database version. The code is already removed, and now say, okay, drop the column. It does not, it's not used anymore, and all of the state has been saved to the new one. So if I now apply this, then it works in this way, that then the database is in the desired state. And this is required in order to be able to refactor my databases to say, okay, now this is what I wanted to have, because then I can stay in a in the perfect state or in a nice code that really represents my domain well. And in order to get there, I have to make some extra efforts in order to enable these zero downtime deployments. Otherwise, I would not be able to make this in this way without disrupting the users. Of course, if I now combine this with what you saw before, that I actually get zero downtimes, then I get I avoid the downtime from both a technical perspective and also from a domain perspective by having a code that always matches this version plus version before or version afterwards in a database schema. And then is one approach and one tool how I can do that. I use this flyway as an init container, so it safely applies all of these rules and makes sure that my database is in the desired state. Of course, it involves some extra effort. So, you see I have this extra migration directory with all of these files here that are applied once after another. But in order to realize this, I get the outcome here. All right, then, so I would just continue a little bit with two more small things. Oh, yeah, which are just a little bit more in general for applying zero downtime for Kubernetes and Istio environments. One that also covers Java applications a little bit is you have to be able to you should be able to gracefully terminate pods. So what it means that you terminate signals are handled correctly in whatever runs in the Docker container. What does it mean? If I tell my application to stop, then it should actually stop. So if I say, under the hood, it says something like Docker stop, and then it should immediately shut down, close all the resources, close the connection to the database so I don't have any resource leaks. Why? If that is not the case, then, well, basically after per default 30 seconds, Kubernetes says, okay, now kill the process. It hasn't been started with 30 seconds. You can configure it if it really takes longer, but it should actually shut down immediately, usually like 1 or 2 seconds. Otherwise, you can get resource leaks. So that is something to consider, because then, it will, you can deploy, much better without wasting some resources. And another thing that is helpful, especially if you do a cluster maintenance, is pod disruption budgets. So you can have a look at the documentation in Kubernetes. That's especially interesting if you use a managed service like the one I'm using here, because I can actually upgrade the version. So this is a very recent version of Kubernetes without having a downtime as well. What it does, it says, okay, if you have my application, I want at least so and so many pods to be there. Because per default, if I say kubectl drain, that's like it's a management command. Drain means, take this node, this physical node, like the physical or virtual server, and throw away all the pods and, deploy them elsewhere. But, it would just either throw it away and then it gets restarted elsewhere, but you don't wait until they are restarted. So what you do with a disruption budget, it says, at least I want to have, where's an example? I think this one. It at least says, okay, have so and so many min available, whatever happens. And if this is not the case, then wait with your management command. So it really tells, okay, wait with the drainage of the node and keep the node there until my coffee shop pods are evicted some elsewhere and build up on a different node. And with that, you can actually migrate and schedule them before you change the node or before you update your Kubernetes node. And this is quite important, because otherwise then you get another planned disruption by saying I need to do some cluster maintenance, I need to upgrade Istio, maybe I need to upgrade Kubernetes, and with that you can mitigate that. And of course you can and should always test it up front. So just to basically at the end say, okay, as some takeaways, make sure that you always verify and properly test your deployments and test the downtime as well. So what I showed you with this Fortio, this was just one example, but basically trying to make sure, okay, is it technically actually possible what I want to achieve, that I get real downtime, and make sure that this is basically the case. trying to regard the compatibility if you have a database. So that is quite important to be able to make database migrations, or at least it will enable you ultimately to move faster. Because what you saw with the database migrations, this was just an example, but it's quite complex. But it really pays off if you then can say, okay, you make this transition here, you deploy a new version, and if you use automation and if you use open source tooling, like for example the ones I showed you, then you're able to deploy really with confidence, to build quality in, to build metrics in with the progressive delivery approach, if you want to use that, and just make sure that everything works as expected. So, oh no, I think I messed up my slide somewhere here. I'm sorry for that. There will be one last slide which says Spasiba. I hope that was interesting for now. We have a little bit more time in the Q&A section where I actually want to answer the remaining questions. And yes, then we can take it from there. So, Alexei, how are you doing over there?
Yeah, I'm cool. Thanks. Great talk. We have some more questions in our Telegram chat, and we also had healthy discussions on releases with database migrations, on backward compatibility, and it turns out that around 2/3 of our listeners do not always make backwards compatible releases with database migrations, and the usual recipes for rollbacks is with pain, with DB backup before release, and so on, with losing data. What do you think? Why don't we always make backwards or forwards compatible releases with database migrations? Is it too hard?
Well, it is. I wouldn't say if it's too hard, but it's definitely not something that is super simple. And I would say the biggest benefit you get is to build some automated process. Like somewhat similar to what I showed you with the migration, that you say you can at least go with steps and then happily automate all the next migration by writing the scripts. But it's definitely not trivial, and it would be more straightforward to just say, okay, we just have a downtime of 10 minutes where nobody can enter the system. We do whatever on the production database, and then afterwards, it works again. But in the long run, for the long-term quality, it's definitely better to think of a process where we can automate things. But I think that's a very good topic for continuing in the Q&A. Otherwise, we will take 2 more hours of discussing that.
Yeah, sure.
Thank you very much. Thank you, Sebastian. Thank you, Alexei, for having this discussion. And I guess you will continue that one, since there are a lot of questions in the chat, as I see. So we'll see you there in Zoom discussion zone. And for those of you who are not there, please follow the link just below this player. Thank you very much.
Thank you.
Thanks. Bye.